Hello, this is Dr. Lori. Welcome to this next exciting video on how to get SPSS to do the calculations for you for the Chi-Square test of independence and for odds ratio. So what I would like, we've already looked at a couple of videos showing you how to do hand calculations for the odds ratio and for the Chi-Square test of independence. And in this video, I'll be showing you how to do that in a couple of different ways. First of all, we need an empty data file. So if I'm in my SPSS computer, I will go to File, New, Data. It will open up a brand new data set just for this purpose. And it's blank. If I click on DataView, there's nothing in it. There's nothing in variable view. And often, as we have seen in our example so far, often we have data that is already summarized into a 2x2 table. And so basically, if you look at the 2x2 table that we've been working out of, you'll see the top left corner has a 19, the bottom left corner has a 1 for controls. The top right corner is a 3 and the bottom right corner is a 37. So those are the numbers that we're going to be using. But you have to remember in SPSS, each row is supposed to represent a case. And so if all we have is summarized data, then we have to find a workaround for that. Also, keep in mind in SPSS, each column is a variable, and so our data is actually going to look different than the 2x2 table. And it's a very important difference because a lot of times people try to enter those numbers in the 2x2 square right into SPSS, and SPSS has no idea what to do with that. So let me start off by doing something in SPSS in DataView. So here we are in the data, and remember that each column represents a variable. This very first column in my data set is going to represent exposure, and I'll label it here pretty soon. But I'm going to call exposure 1 being exposed. I'll make 2 rows. You'll see why in a minute. And I'm going to call exposed 2 means not exposed. So here I have 1 is exposed, 2 is not exposed, and then the second variable that I am going to be entering in is going to be my disease. And so I'm going to say that 1 is the cases and 2 are the controls. And so let me repeat that. 1 is cases, 2 are controls. Now, before I go any farther, one of the things that's going to be really important to do is for me to keep track of which ones these are. And instead of just writing them on a piece of paper, I'm going to go to variable view and I'm going to code them in there. So variable 1 is going to be exposure. I'm not sure. Here we go. And then variable number 2 is going to be called disease. So if I go back to my data view, I see that my first column says exposure and my second column says disease. Let's go back to variable view, and now let's tell the computer what do the values mean. So if for exposure, I go to this top row. If exposure is a 1, that means exposed. And then I click add. If exposure is a 2, that means not exposed. Click add, and then OK. When I go back to my data view then, it still says 1 and 2, but if I click this little toggle switch, you can see that I can change that. Now it knows that the 1s and the 2s mean exposed and not exposed. If I were to go back to variable view, then I want to do the same thing for disease. Remember how I said number 1 is going to be cases, and number 2 is going to be controls. So So I click OK. When I go back to DataView then, if I click on my toggle switch, I have exposed cases, I have exposed controls, I have not exposed cases, and not exposed controls. If I toggle back to the 1s and 2s, you can see I have a 1-1, a 1-2, a 2-1, and a 2-2. So that just means that I have all possible combinations of 1s and 2s. When I toggle it back to what it actually means, I also have all combinations of exposed and disease, exposure and disease. I have all the 4 different quadrants of my cell. So remember in that top left column, or sorry, that top left cell, it's on the exposed row and the cases column, that number is 19. So I have 19 exposed cases who are exposed. I also had 3 controls who had been exposed. If I look at my not exposed cases, that would be a 1, and my not exposed controls, that would be a 37. Now, an important thing to remember is that in SPSS, since each column is a variable, this third column where I put in my counts, remember we're doing this in terms of using summarized data, I should probably label that and say that is the number of cases. I think the kind of standard would be just to say number. So I think that's pretty straightforward. So in other words, I have 19 exposed cases, 3 exposed controls, 1 not exposed cases, and 37 not exposed controls. I don't need to do anything with row totals or column totals or anything like that. So now I have entered my data. The steps that I just showed you completed everything I need to enter data. The other thing to keep in mind in SPSS is that each row is supposed to represent a case. Well, this top row actually represents 19 cases. It represents 19 exposed cases. And then this second row represents 3 exposed controls. So I need to tell the computer that these numbers under number really represent a weighting value. So if we go to data, weight cases, I'm going to tell it to go ahead and weight the cases based on that, whatever is in this column right here under number, to weight my cases based on that. I click OK. If I notice here, it says weight by number. So it's keeping me posted in terms of all the things that I've done so far. So back to my data. I have now indicated how many each of these represents. And the final step is to actually calculate the chi-square test of independence. And in SPSS, this is called the Pearson chi-square. So I'm going to go to Analyze, Descriptive Statistics, crosstabs. And under Analyze Descriptive Statistics crosstabs, that's where I find my chi-square test of independence. Now, the important feature of a chi-square test of independence is that I have 2 variables. I have a row variable and I have a column variable. So just looking at this crosstabs reminds me that I'm probably in the right place. My row variable, by convention, the way I like setting it up, is going to be my exposure. And my column variable, I like to have my disease there. If I do it the same every time, then that just kind of helps keep everything straight. Under statistics, I need to ask for the chi-square statistics, and this is what gets me my Pearson chi-square. And then I'm also going to ask for something called risk. Now, technically, we're not asking for risk, but risk also includes in that particular output box, it includes the odds ratio. So not just relative risk, but odds ratio. So let's go ahead and click continue there. We've asked for statistics. And then I also want to ask for expected values. Observed is the default for each of the boxes. And remember how in a previous video we calculated what the expected value would be? It's kind of nice to be able to see those in the cell next to observed so we can get a sense of which cells are not as we would have expected. We don't have to then do the calculation of expected mentally or with the calculator. So I'm going to click OK. So in summary, I've put my exposure as the row variable, my disease as the column variable. I asked for the chi-square and the risk, and I requested under cells my expected value in addition to the default observed. And so now I'm going to go ahead and click on OK. And here is what I get as my output for that, and it goes down a little bit farther. This first output box tells me I have 60 cases. That's what I was hoping for. In this next one where it has exposure by disease, I can even see my disease cases, disease controls, and the numbers 19, 1, and 20, 3, 37, and 40. And then here for exposed is on top, not exposed is on the bottom, and then each cell also has the expected count directly below the observed count. And with any comparison, you can see that this matches what we did as our hand calculation. The next output shows us the Pearson chi-square value here in the top left, and then this thing that says asymptotic significance, that is your p-value. See if I can get rid of that. Two-sided p-value right here, 0.000, so that means it's less than that. That it rounded to be less than what looks like 0. And then in this final table, here's where you'll see your risk estimate. The top number is our odds ratio for exposure, exposed to not exposed. And here's why it's so important when you're in the data entry piece to enter these as 1 and 2, to enter them as numbers rather than calling them exposed and not exposed. When they're numbers, SPSS automatically alphabetizes. So if they're numeric, it starts with number 1 and then number 2 and number 3. If the coding is alphabetical and it doesn't alphabetize properly, then you might end up with an odds ratio where it's the not exposed over the exposed and get a number that you have to convert and confidence intervals around that number that you have to convert. And so when you enter it as numbers, then you have control over which one you assign to be the number 1 and which one you assign to be the number 2. So that's why I like using numeric codes and then coding those values. So that's all of your output for that particular analysis. Thank you for joining me.